So let's talk. Let's turn our eyes and turn our tables to a different kind of important person at NASA. Is that, well, I'll call them typically the unsung heroes. Is what you did, the chief engineer. You're in charge of taking these crazy ideas, making them real, testing them out, and seeing what we can what comes of it. How did you get inspired in aviation? How do you?
Okay,
Tell us a
so
little bit. Tell us a little bit about who you are, and then how you got inspired. How about that? Because I just realized people don't know you. People don't know who you are. I do, because I've been watching your Prandtl D work, and thereby learning more about you as I go. But what
um,
should our listener know about you, Al?
not a normal childhood by a long shot. Um, my I'm a Japanese American. Okay, my mom is Japanese. Um, she was she married my dad in the late 1950s, and Dad was Coast Guard. He was an electronics technician, and
Hmm.
they were doing Loran. And you stop and think about, again, tube amps, right? And they're using um, analog systems in order to determine the speed of light of these radio waves and the return. And
Hmm.
that's the way you're navigating, because it's this that's how Loran works.
Yeah.
And so um, Dad has this clearance because of this work that he's doing, and he goes and marries a foreign national. So the next thing they do is they yank his security clearance, so he can't work on that stuff anymore, and he ends up with really garbage jobs. He's always away on the ship. The only language we spoke in the house was Japanese. It took my mom and I 3 years before we could file all the paperwork and everything. I was a U.S. citizen, but my mom was foreign national.
Hmm.
Okay.
And so it took us 3 years to finally get it all straightened out, and we could finally move back to the United States. And so,
Oh wow. Yeah.
yeah, and so only language that was spoken in the house was Japanese up until the time I went to kindergarten.
Okay.
And first day I had to speak English was my first day of kindergarten. And I was in remedial English until I was in the fifth grade.
I believe it.
And I could do math.
Right. Yeah, because that's a
Okay,
universal, right?
exactly. And so this is the piece of the puzzle that um, it's the reason people couldn't write me off as being um, uh, someone who was unable to function. And
Hmm.
so finally, fifth grade, I come up to parity. And so we, right after I started hang gliding, my dad gets a job reassignment. By the way, he gets out of the military and ends up working for TRW building spacecraft.
Okay,
And
cool. So
if
you've
you,
been in that industry.
oh yeah,
Well, the family's been in that industry. It's something you've been around
yeah,
for
oh yeah.
most of your life, if not all of it, right? And
I
by the way,
wasn't
low ran is, what is it? Low frequency radio signals, right?
relatively, yes.
Well, I'm just
It,
like, that's the system, right? It's a hyperbolic radio navigation system using 3 transmitters and a bunch of certain kind of configurations. So you can, like you said, tell where the heck you are and where
yeah.
other things are in relation to you, so you can get where you want to be.
Well, if you're a private pilot, you might remember when Loran came up and was available prior to GPS, right? There were a lot of
Yeah.
guys who were putting Loran systems in their um, home-built aircraft and their commercial um, aircraft, and so Loran systems came down in cost. And then all of a sudden, GPS came along.
Right.
In
Solved all the
about
problems,
1990, yeah, right. And
so to
so
speak.
now, yeah, and all sorts of headaches associated with that now. Um, but anyway, we ended up moving overseas again, and English is not English in Australia.
No.
So ended up at a facility that was down there, and the old man couldn't tell me what he's working on, but I have pretty strong ideas about what they were watching, and
Okay.
from GeoSync, and so anyway, when I finished high school in Australia, and by the way, while I was there, I couldn't fly hang gliders. I wasn't old enough. So I went and I flew
Okay.
sailplanes instead. And
Okay.
so this is my background, hang gliders and sailplanes. And so I end up finishing high school and I come back to the United States. And I went to Cal Poly, San Luis Obispo, out here on the West Coast. And which is actually kind of funny because my high school was in Redondo Beach, LA, which is where
Okay.
TRW was, where my dad was working. And both schools are on Pacific Coast Highway.
Oh,
Uh,
okay.
the high school I
Okay.
went to in the United States and Cal Poly, San Luis Obispo, both are on the Pacific Coast Highway. So
Nice.
um, anything
Still
east of the
connected.
Pacific Coast Highway is back east, California thing.
I hear it. Well, what is it
But
now? The five? Is it the five? I'm
no,
sorry.
it's
I was under San Diego, and they're like, "Oh, we're gonna go on the three." I'm like, "Wait, what?" And they're
it's
like,
the
"No,
Highway
the
One.
right, the one." And I'm like,
Yeah,
"You mean I won?" And like, "No, no, we just call it the one." I'm like,
yeah,
"All right, the
one.
local lingo, got it. Thank you." So,
It's
because
Highway
over on
One,
our side where it's 95, etc., so we call I-95 because it's an
right?
interstate.
And
And they're like,
yeah,
"Yeah,
and the
you gotta."
I-95 corridor, right?
Right. I'm
Exactly.
like,
Hmm.
yeah, and yeah. The difference is we go from state to state pretty quickly, whereas California, you just travel and you're still in California. So, you mean it changes other states? Anyway, I
So this
digress.
this is this is how I get to where I'm at, and
Yeah,
um, there was this girl, and I wanted to keep going to school, so I went to grad school, and um, she's been married to me for over 40 years now, and
bless her heart.
yeah, yeah, it's all on her, not me.
Yeah, yeah, right. Congrats, congrats to both of you. That's a really amazing achievement. I mean, it's not an achievement, but it's an achievement. It is. It's I don't know too many people who've managed that. It's not easy to do. So good. Okay, so that's who you're. But okay, so you went to school. Would you go to school to study?
Aero engineering,
Okay,
and for my master's degree, um, it was another aero engineering type. Cal Poly, I was literally the third person to get an engineering master's degree from Cal Poly San Luis Obispo. Um,
okay. Was there
and
was there a concentration that you had? I know as you go higher up in education, you get tighter and tighter in focus. What
yeah, it was an aerothermodynamics
thermodynamics?
degree.
Okay,
Yeah,
yeah, yeah,
and
good.
so that's what I was concentrating on, and that's what's on the degree.
Hmm.
Um, and NASA paid for that. And so
Awesome.
as soon as I
So
finished that,
so NASA had approached you and hired you beforehand and said, "Hey, finish your school, and when you're done, you're
I,
ours." And I'm making
I'm
this kind of grabbing motion, but
kind of, but there was no guarantee of that. And
okay.
but when I September, September 2nd was my last final. September 10th, we got married. September 26th was my first day at NASA.
Oh wow, what a busy time, right? So exciting. That's
Yeah.
so cool.
Had to have been
Well, cool.
terrifying too.
Yeah, right.
I don't know.
Terrifying.
The that many rapid fire things, exciting, but also, man, there's a lot of changes in life right now.
Yeah,
Right. Well,
yeah.
when you're young, you just don't, you
Yeah,
don't
just
even
roll with
realize
it.
that you don't know any better.
Yeah, I
Yeah,
guess.
you just sort of go with it. So when you got hired by NASA, right now, I think in general speaking, and it has been for most of my life, NASA is one of the top end organizations to be part of when it comes to engineering and aerospace and space, right? I don't know how was it, because in the 60s and 70s and 80s it was still the hotbed of, we'll call it invention, the hotbed of testing, right? And that's what I didn't realize at first. I thought NASA was just, they're the people who put things into space, right? Like that's my childhood. That's that's the only thing NASA is for, right? And then I'm like, no. I think then Red kind of explained to me, he's like, no, NASA. And then when you look at the NACA papers and things like that, like their job really is to test ideas that may have fruit in the aerospace industry, but it's not a sure thing. So
Yes.
somebody's gotta check it out and be willing to take the risk. And it's a public service in the sense that this helps move America forward, right? And anybody really, but America's the goal, right? Because this is in America. So the goal is learn what you can, and if it proves itself, then it gets adopted by the industries that are going to make money with it and help people do things. Like they're making money because going faster from place to place helps people do more business, right? Or et cetera, that kind of thing.
Right.
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 Being able to put things into space achieves a number of goals that are impossible otherwise. People pay big bucks for the thing that's impossible, and thereby it's a viable industry, which is why people pay big bucks. But to get there, to test that, somebody's got to foot that bill.
Somebody has to go do that.
Right.
And
And
that was
somebody
our
has to be
job.
saying it's worth doing that. And that's the government at large, because the government's saying, hey, look, we want to be a better thing, and nobody can individually do that, but we have, it's worth it. Let's try it. So
I've got
you
a
guys
picture I've got
do
to
it.
show you. I've got
Okay.
a picture I got to show you. And this was one of my first big projects. Can I get the screen here for a sec? All right. Let's do small. And I will do this. Okay. And so this was an experiment that we did. And
I don't
the
know
person
that
who,
we're getting you, Al.
you're not getting it?
I can see it.
You
I don't
can?
know. Yeah, and his head is in the corner. That's really awesome, actually. So it's a Boeing 720 controlled impact demo, which
Yeah.
is, and was this one of the things that you were part of in the
Yeah.
beginning? Okay.
Yeah.
And it was
So
basically trying to find non-explosive fuels, as it were.
the idea was that they would have a fuel that would not explode or burn during post-impact fire. And so about 20% of the accidents, fatalities, from 59 to 79, and this is within the United States,
Right.
was because of a post-impact fire. And so this was the primary thing that they were testing, was this anti-misting kerosene, AMK. But the thing that there was a lot of pressure just to go fly the thing um, and just get the pictures. That was all they wanted.
Oh, geez.
But
Right. But
but we
where's the value in the pictures, right? Other than to sell.
right, or if it goes wrong, how do you know what went wrong
Right.
if you don't have that instrumentation? So
Right.
we fully instrumented everything, and we got in more trouble with Washington D.C. over that.
Of course.
But we were the first ones to use crash test dummies that were not 85th percentile males. You'll notice there in the picture that there's a kid strapped in.
Yep.
And we were the first ones to have small kids, crash test dummies for small kids. And
Right.
we also did 15th percentile females. And so those crash test dummies also got put in. One of the things we discovered, and this was the test, the seats would survive the crash, but the people strapped to those seats would not,
Okay.
because
So the seat
they were
would.
trained. Yes, the seats were too strong. They were transmitting the loads to the people. And
Oh,
so
no
since that
absorption.
time,
Yeah.
yeah, exactly. So now the seats are meant to, if you look at them carefully, there's actually the tubes are bent in an S shape so that
Yeah.
they fail gracefully and don't transmit the large loads to people.
Right.
So the seats will break. And so if you're ever in a bad accident, I hope anybody who hears this
Let's hope that never
never
happens, right?
never happens, exactly, right? But you will find that you have impacted and the seat is broken and you can get up and get out of the airplane. And that's because of this test.
That's so awesome.
And
And it's the data, it's the putting the stuff in so you know what's causing the success and the failure.
right.
That's almost more valuable than the test. It's obviously doing the test is still hopeful, but
And,
really being able to determine what direction to do the next test in is
right.
probably where you're really saving the money and truly gaining, honest knowledge.
As who the two guys who did the aerodynamics for the approach to the ground because of the ground effect
Hmm.
and the pitching that would occur to the aircraft prior to the contact with the ground.
Hmm.
Um, there was me and one other young guy, and so you had a 23-year-old guy and a 24-year-old guy that were doing this.
So was this a remotely operated vehicle then? I'm
Yes, it was
assuming.
a big
Okay.
model airplane.
All right. Just so we're all aware, this is still topical thing.
Right. Okay,
In
so
case you're like, what the
now,
deal? Okay, so that was like your first baby, right? That was the first one you
yeah,
worked on for NASA,
yeah.
which has subsequently changed the way airplane seats were designed and failure modes were better understood because of that. Thank you, Joe,
Long
for
answer to a simple question.
no,
Those are the
but
best
it's
answers.
good. So was it the hang gliding? Or your interest in aviation was because it's pretty much how you grew up.
Um,
Maybe I missed it, and I mean I understood it, but I was like, was there a moment where you hit a spark where you're like, oh yeah, I need to do this forever?
um, my parents tell me that the third word I learned was airplane.
That
Um,
sums it.
mom, dad, airplane, and
Yeah,
that it was just. I've been an airplane nut my entire life. The growing up during, I remember watching the launches for Mercury, and then Gemini. Every 2 months there was a launch.
right.
It was just amazing to watch. And then of course the entire Apollo thing, and then um, last Apollo mission gets flown in 1975, and I don't get there until 1982, and
Ah,
so I missed it by 7 years. Right?
that much.
Sort of. Um,
Right, but all the
and
people that you're working with were
right,
part of that group, right? So you were able to really kind of pick their brain and learn from their experiences on that project.
and
Were
the
they doing
X-15
the
guys were still there, and
yeah.
yeah,
Oh, that's so cool. Is that where you got so I don't know. I don't know if I should, but I mean you shared with me a really really cool picture of we'll call it astronauts in transit is what I'll call that one. Um and I shared it with Joe. It was with a convertible with a bunch of guys in there. It's I will call it a bunch of knuckleheads, but if you know who those people are, they're clearly not, they're famous knuckleheads if you want to call them
yeah,
that.
they
Um
were.
but yeah, if you could substitute whoever they are with almost when you're growing up, your buddies tooling around town having a good time. Like that's pretty much what you guys look like you were doing there.
Exactly. Well, the thing was, in that particular instance, they were coming back from lunch, and
Okay.
and the gate guard was the one that took the photo, and they were good buddies at this point, and um, Gus Grissom is in the back seat. He's giving the middle finger to the guard. The guard snaps this picture. And that is just the way these guys, the fighter pilots and test pilots, would greet each other.
Yeah.
And so um, Thompson, the X-15 guy, he had this old Jag that he drove around all the time. And he would go everywhere at 80 miles an hour. He got stopped by a cop for speeding one time, and he had forgotten his wallet. And so he takes out, he opens the glove box, pulls out a ticket that he had been given, just the day before. And here, can you use this as an ID? And the guy wrote him a new ticket, and he stuffed it back in the glove box, and off he went. Milt, when he, if you were one of his friends, you would get the middle finger. And I had a Honda Civic at that time, typical engineer, right?
I had a
And
buddy like that.
carpool. There were four of us in the carpool in this little Honda Civic, and we'd be tooling along at 55, saving gas, right?
Right.
And
Yeah.
Milt would go sailing by at 80 miles an hour in that Jag, and all you'd see is his middle finger as he's going by, and him laughing the whole time. And
Yeah.
so the next day, he'd come by the office, he'd look in the office, and he'd start laughing, and you'd have a good chuckle. I mean,
That sounds
it
like
was
a
just
good environment
amazing.
to work in. Yeah, it sounds like a lot of fun to work in.
Yeah.
Speaking of,
We had
go ahead.
multiple old guys at the place that were NACA guys. And by the way, it's always NACA.
Not
You
NACA.
never pronounce it as a word, okay? And
Okay.
once it flips, you never pronounce the letters, okay? It's
Okay.
always NASA.
Right.
So and there's sort of a distinction that goes with that.
Now, was it because of the way the change went about? Was there a certain stigma, or why the distinct, like, oh no, we're not them, basically, right? It's like, oh no, we're not those guys anymore, or was there a regime change when that happened?
There was
Is it
sort of a regime change at that point. And there was also the switch in the mentality about, you used to be the organization that was hoping that airplanes would just go higher and faster and eventually get to space. Now
Mhm.
you're the organization that's leapfrogging the whole thing. And
Yeah.
that's
Okay. So you were
mindset
the
that
guys
goes
that
with it.
ruined the fun time, as
Yeah,
it were, right? Like NASA is like, oh, you kind of, I thought we were going to do this forever, and well, shoot, I guess we're going a different direction. All right.
yeah.
Interesting. Interesting. Because I always wondered what, like, I mean, I know why the shift, right? All of a sudden we can go into space. It should not be called the same thing, right? It's a different ball of wax at that point. Um, so there's a number of questions that we have, and I haven't looked through all of them, but I read through a handful of them, and some of them have a similar gist. To, I'm an engineer, I'm a structural engineer, but I think a lot of people who love aviation, they're either looking at how does one get to be an aerospace engineer, or more importantly, and I think this is probably the crux of some of it, is what does the life of an engineer look like? What does it look like to be the chief engineer at NASA or an organization
Oh,
similar?
okay, so the career at NASA, I was an aerodynamicist engineer for 20 years. And at that point, I moved into the management ranks a little bit. I was the chief
Mhm.
of aerodynamics.
Okay.
And then from the chief of aerodynamics, they made me the deputy of research, deputy director of research.
Okay.
And so then Washington, D.C. sucks me in for 6 months. And I went
Oh
to
no.
Washington.
The
Went to
the
Washington
quagmire.
D.C.
I'm just kidding. I'm messing with you. That's a
No,
good thing.
those people really are crazy.
It's a different, well, they're dealing with a different type of person, right? So I'm assuming they're the people who are talking to the politicians and making sure that the right projects are being moved forward,
Right.
and they have to convince people who are like, I don't want to do any of this, right? They have a different role primarily,
And,
right? Their job
and
is not to research primarily. It
right.
seems like it's to make sure that the money for the research stays. And then there's the other facilities that are designed primarily to get the actual we'll call it the nitty gritty done, right? The experimentation, the let's develop this further, let's see where this goes, that kind of stuff.
And Washington, D.C. is also crazy in another way. When you go to lunch, you have
Did
to
you
take
like
your
it?
badge. Yes and no. For a short period of time, yeah, you can
Okay.
do that without getting sucked in. But
Okay.
when you go to lunch, you take your badge and you put it in your pocket
Right.
because you're in the environment across the street from the congressional office buildings. So you're in the line waiting for lunch with staffers. And so the last thing you want to be talking about is griping about how the money's being spent. You have to be very careful
Yeah. No,
because you do not want to embarrass your boss.
right. That comes back to you very quickly.
Yeah. So I came back from that. I was a project manager for 3 years. And then I went back to the research side and I started working on this particular problem most of my time, the whole Prandtl thing. And
Okay.
from that point, I was not the chief engineer at our place. They it was they asked me. I told them I couldn't do it. And then the director is telling you you have to take the job. It's like, ugh. So they made me the chief scientist.
Okay. So at that point, does that mean you're focusing on research primarily and less about the testing of
Um,
the idea? Do you know what I mean? They're right. Like science is about taking the concept and running through and doing the test, right? And
and
and engineering is about like, well, we have this thing. We need to develop a model to further test it or to see more details on it, right? We want to iterate now. So let's do something that we can do more than just one test. Is that correct?
it is, but there's also the piece where with the science side, you're trying to look at the experiment and what are you comparing the experiment to? Do you have
Okay.
analysis that you're trying to match that up with? And I mean, that's what we were trying to do was to
Right.
prove
Yeah.
beyond um to prove that you were actually getting what you thought you got when you did the math.
Okay. Right. You're saying, hey, we looked through the numbers, we did all the things, and it says this should happen. So let's test it and be sure
Right.
that it does happen, or be sure that what we're doing is actually yielding the thing we thought. Or if it's something different, like, well, let's look at why. Right. Um,
Because there's this really old,
it's okay to be different than what you
incredibly
thought, right?
obscure paper that nobody looks at, nobody is paying attention to, and if you read what it says, if you believe what it says, we should all be doing that.
Yeah, I think what you're talking about. And I have one question before we go that direction.
Okay,
Right? I'm assuming you're talking about what led to the Prandtl Wing project to begin with, right? You
right.
started becoming chief scientist, and with that, somebody said, "Hey, see what the deal," or you, and that's what I want to get into is how did that come about? Because that's one of the listener questions. Um, but before you do, you worked on a number of other projects. You talked about the one with the
Well,
um, non-explosive fuels, which led to a completely different discovery, right?
that's right.
Wait, but also still a very positive experience. You had a number of other like the oblique ring. You had I don't even like some of these things are foreign. I didn't get a chance to look them all up, but give me like maybe the top three projects of the ones that obviously you have the Prandtl wing. You have that. What are some of the others that you were?
We put thrust vectoring on an F-18. And the way we did it is the crude way that no one would actually produce. We put three vanes around each of the nozzles on an F-18, and we built a new flight control computer. You should never, the old rule was you should never do propulsion and airframe development at the same time. The
Okay.
new thing that we've come up with this thing that it absolutely weighs nothing, but you can expend huge amounts of money trying to get it to where it will function. That's called software.
Oh yeah.
And so this is so we built a special flight control computer. We could flip from the standard F-18 control laws to this, we called it the research control laws that you were flying. And most of
Okay.
it was associated with this thrust vectoring. We also, I was one of the people that promoted this. We were trying to do this to get aerodynamic data. I realized that this was the test bed for all these neural, fuzzy logic, dynamic inversion, all these different kind of control laws that were coming up, advanced control theory that had never been flown. Who do you end up, how do you end up doing that? And the big issue was, how effective are these vanes on the back end of this airplane in order to get the forces and moments out of it? And I thought, oh, this will be easy. I'll just look up what other people have done before,
Sure.
and I'll just turn this into a model. And
Should be simple.
yeah, I'm 27 years old, and I am the single
Yep.
point failure for $500 million.
Oh,
Okay.
yeah. Yeah. A little bit of
And
stress.
and so the project manager, who is gone now, and very, very good friend of mine, still talk with his daughter. She's a journalist. He says, I need it in 6 months. And I'm going, oh man, it's something nobody had ever done before. Well, it turns out it's a 9-dimensional space that you're trying to create this particular model in. And so I got 2 interns to help me. And we were the only 3 people at the whole center that would sit down and talk about 9D solutions.
Right. There's
Solution space.
3 degrees of freedom in general because it's a free body.
Right.
Right. You also have the vector
My
of
name
the
is the
thrust.
4.
Right. But then you have another for the vector itself, the actual thrust nozzle.
Right.
Or the vectoring of it. That's a related but separate set of freedoms. You also have time and how fast from thrust to actual
So
directional
then you also
shift
have the diameter of the nozzle
Oh,
itself.
yeah, there's
Okay.
that.
And
I
then you
forgot
have
the F-18 can do
nozzle
that.
pressure between inside and outside. So if you're at 40,000 feet versus 20,000
Right.
feet,
Yep.
okay, so you have to map that, and you can see what happens. 9 dimensions.
It's easy. It's just easy. It's a program.
Yeah.
You just write it. It should be easy. Right?
We had about 170,000 data points from the wind tunnel test. And we needed 2.4 million data points for the model. And so we came up with a way to create that.
So you kind of use those originals as a basis. You extrapolated some of the rest and used that to be able to create your model.
Yeah.
That the software utilized. Is that the HARV system?
It was.
High Alpha Research Vehicle. Thank you, Rara. He was
he dug it up.
Well, no, that's one of it. He loves the F-18.
Yeah. Well,
He's like, he gets very excited. I mean, we all kind of do, to be honest.
I was the chief engineer on that. There were 7 chief engineers of that aircraft. I was the last.
It sounds like you were the successful one.
I got to capitalize on everybody else's hard work.
Sure. I was going to say, and I've done that where what I find out after I'm, like a month into the project, I find out that guy's worked on it. And before him, this guy worked on it. And before him, that lady over there worked on it, and then she was passed to it by the big boss, who at the time was much younger, and and you're like,
right?
well, how many spots has this one thing been
Yeah.
designed in? They're like, oh, well, it's here, here, and then there was a 10 iterations before they selected the first one. You're like, oh my god, so it's never going to get built. And they're like, yeah,
Yeah.
well, our client's still paying us to do
So
the thing. So
I did F-18 Harv. I
okay,
worked on
excellent.
SR-71s for a while.
Which what piece of that? Because I'm sure it's not the whole deal, right? It's got to be a part, because there's so much to
So
it.
and when the Air Force was all done with the SR-71, they bailed the last 4 airframes to NASA, and I was the one that we had to sort through everything, all the paperwork, and figure out what we needed in order to be able to put the airplanes back together. And
Oh
we
wow,
made
yeah,
2 flying airframes out of the 4. And yeah.
that's cool. That sounds
That's
like a
not a
fun
terrible
project.
ratio, honestly.
For something that was out of production and there were no spares, I mean,
Right.
we made stuff up, you know?
Yeah. That I mean, there's little bits of that design that just still the fact that the what is it? The propulsion fins were monocrystal metals grown, and I'm like, wait, what? I looked and I was like, oh my god, that's incredible. Because it yeah, it's just one of those, again, just that's a whole rabbit hole that I think
Yeah.
we'll have to revisit. But I saw one at the was it Uday? I can't ever remember. Then
Verhazy.
Verhousing, yeah. We went there with my kids a couple years ago, and
Yeah.
it's the one of them is front and center, which is wonderful. It really makes a great impression
That one is the
with the
fastest
space shuttle
airframe, by
right
the way.
behind it. Yeah, what?
That one is the fastest airframe.
So
972.
with how
So there's differences in speed between the airframes.
Yes. Yes.
you're like, oh yeah, big. We
Yes.
how, that's so cool. I don't know. It's just one of those things. To me, they all do the same thing, right? I guess
No,
because I'm
it
thinking
was
like
not.
F-18s. You just as long as it's that model, it does the thing, right? And obviously SR-71. There's I guess were there a bunch of different variations then? Is
It has to do mostly with you're talking about hand-built aircraft, right? And so
more or less
eh, inevitably there will be one that ends up with the straightest airframe that
okay.
has the most honest handling, and because of all that, pilots trust it the most. And
Okay, so
so
they're willing to push it harder. Yeah.
which airplane can you push that hard?
Okay. Yeah, and not worried that it's going to come to pieces on you.
Yeah.
Because at those speeds,
Um,
that's what happens, right? That's
the
part of what
third
I love
project
about
that I
Yeah, go
got
ahead.
to was a really cool one. Was we had some guys who wanted to tow a Delta Wing airplane up. I mean, literally tow like a glider when you would tow launch it. And so we needed a tow plane. We used a C-141, and they had a special instrumented pallet that they bolted to the floor. And they would throw a parachute out the back and deploy the parachute. And they would check the loads on the parachute. Then they would cut the parachute free, and they would get all the data from this pallet that they had
Palette.
bolted down. Well, we put a 1,000-foot tow rope on it. We put a B-52 parachute release mechanism backwards on the nose of a F-106. So we towed an F-106 like a sailplane. And Forger was our pilot for this. And flew 6 flights that way. And we were the first ones to get aerotow data and
Okay.
all the dynamics and everything associated with that.
It's a Delta Dart.
Yeah, I was looking
Okay.
up a picture of it now.
Yeah, we're looking. We're like, oh, what's an F-106? Interesting. Yeah.
All-weather interceptor aircraft.
Transonically, that thing
It's,
runs away from an F-18. It's amazing.
Okay. Interesting. So was the purpose of the towing was the point of that like it takes a lot of fuel to get into the air for this aircraft to get up into the air and up to speed like a we'll call it halfway decent speed, let's say 100 or 200 miles an hour, let's say, and then you release and off it goes. If you can get it from there to the 200-mile-an-hour part from the ground in there, you're saving so much fuel, it extends the range incredibly. It's worth doing. Or was it
We
something else you were testing?
no, it's a space launch idea.
Oh,
Tow
okay.
plane is the first stage.
Okay.
So you have this delta wing space shuttle type looking vehicle that you would launch off the back of this tow from 40,000 feet. You would go to Mach
Okay.
8, go to 100 miles altitude, put the satellite out with a kick motor on it, and the satellite goes into low Earth orbit. You re-enter and land, and then you put another satellite in the thing, and you just go do this one after the other.
Right.
How cool of a job would that be to have, though?
Right. How cool of a job was that, Al?
It was pretty cool.
That's awesome.
Mm.
So did that change how people or was that like a concept idea of like this might be a viable way to send low Earth satellites up for pennies on the dollar compared to, stick it in a bundle with a bunch of them to the top of, a rocket and just, send it.
Right. But I mean, step back and think about this. What we had not counted on was that thermal protection system materials would improve so rapidly that they could make a much smaller space shuttle type device that could be
Hmm.
launched internally to the shroud on an expendable, and
Right.
that's X-37,
Right.
which
Yeah.
the Air Force is using to do all sorts of things with already.
Right.
So the capability there kind of cascaded. Um,
Right. Yeah, I
and
mean that's
and
the nature of the business, right? Where everybody's pushing a boundary in all the different ways. You don't know which one's really going to hit that mark
exactly.
until you're already doing it, and you're like, oh, whoa, this we can do. That is promising. If this weren't that much better,
Yeah,
if this weren't seeming to be the one to go for,
yeah.
but then you get to, but yeah, that's really cool. You get to, uh, that plane is beautiful. The
Oh
F-106.
yes, yes, gorgeous.
I'm
Yeah, I
sorry.
was looking at the X-37.
Right? Oh my
also,
gosh.
also an impressive piece of hardware. Very
Hmm.
cool
I
hardware.
I bet. Really cool. I mean, yeah, and these are one of many, right? Obviously, how long did a project tend to take? When you got to sign a
Um,
project, what kind of timeline are we looking at? I know mine tend to be people want things built and making money for them within, 2 to 3 years depending on the industry, right? For what I do. I do building stuff. So,
right. Our F-18 Harv, it was 11 years.
okay.
And in 11 years, we did 396 research flights.
It's a lot.
That's a couple a
Uh,
month,
I'm- yeah,
and probably not evenly distributed.
right.
No, no.
So you
The Air
you get a
Force,
bunch of tests lined up and then go run them?
um, our aircraft would spend long periods of time all tore apart, parts all over the hangar floor, and putting the next experiment on the airplane. Then you'd eventually get it all put back together, and then you'd go out and you'd fly it maybe 20 flights. And so, in the course of 3 or 4 weeks, 3 or 4 months tops, you would get all the data, and then the airplane would come back and you'd tear it all apart, and the next experiment would go on the airplane. And it would be a year and a half until you would fly again. This would drive the Air Force nuts at our place. Um, they always viewed us as being um, the science experiments run amok. Um, And because they want to get flight rate, they want to know how long, what's the fatigue life on this thing. They want to know uh, what's the turn rate on being able to turn the thing on for operational sorties. Those are the kinds of things that they want to know. And
you're like,
we're tearing the airplane apart. That's not what we
the
do.
point. Yeah, that's not the point, guys. We need to
Exactly.
reconfigure this and give another set of tests. I don't care how fast it can turn. I don't care how it does all these
Exactly.
other things. What
You
I
take
care
our
about,
data and go do your own tests.
yeah, if you want that, you go do it. Oh, we're trying to figure these other, seems like larger questions. Really cool. Okay,